Welcome back, everybody. We're going to do our second day of 8.5. So yesterday we talked about how to solve a log equation, but there was only a log on one side of the equation. Now what are we going to do whenever we have logs on both sides of the equation? So if you look at 5, 6, 7, and 8 on your guided notes, remember they'll already be solved. This is just a description of them. So you can rewatch this and see if things click a little bit more after you watched it a couple of times. They'll actually be a little bit easier to solve because there is a property of equality of logarithms rule. And it states that if you have a log on the left side and the right side and their bases match up, now that's pretty important, but this happens in all these scenarios, then you can simply disregard them and set the arguments equal to each other. So again, today might be a little bit easier for people. So whenever I look at number 5, I realize the log base 3 matches up with the log base 3. If that is true already, you just need the arguments to equal each other. So you get to forget about the log base 3's and only take the arguments equal each other. So in this problem, you could simply write x is equal to 7. Now there's no solving to do, but before you box it, just check your answer meets the restrictions from yesterday. Remember that a base has to be a positive number when you plug the answer back in, but it can't be 1, and the argument has to be just a positive number. So when I plug in 7, that makes the argument a positive value. It's a valid solution. Number 6, very similar. So in number 6, you guys, you'll see that you have a log base 4 on the left and a log base 4 on the right. You can simply disregard them in this scenario and set the arguments equal to each other. So when we do this, we have x plus 2 is equal to 5x plus 2. And we'll solve like normal. I'll minus x on both sides. I'll minus 2 on both sides. And I'll divide by 4 to get 0 is equal to x. Now, whenever I look at that, I might think, well, that's not a positive number, so I can't keep it. Again, it's not what your answer is, it's when you plug it back in. So when I take 0, 0 plus 2 makes a positive argument. I'm good there. When I do 5 times 0 is 0 plus 2, it makes a positive argument there, so it is a valid solution. Remember, your answer doesn't tell whether it's okay or not. You have to plug it back in and follow the restrictions from page 1 of your 8.5 notes. All right, you guys, number 7 and 8, very similar again. You'll look at it and you realize the logs match up. So you're going to disregard log base 9 and set the arguments equal to each other. So now I have 1 minus 2x is equal to x minus 5. And I'll solve by adding 2x on both sides, adding 5 on both sides, and then I'll divide by 3, giving me 2 is equal to x. Now again, if you don't really understand the restrictions as well, you might think right now, it's great, I got a positive answer. It's not your answer, it's what happens when you plug it back in. So when I take 2 and I plug it into this argument, I have 1 minus 2 times 2 is 4. 1 minus 4 is negative 3. Negative 3 is not allowed to be the argument of a logarithm. It has to be a positive number. So when you look at that, we say that it is not valid. We can call it an extraneous solution from previous sections. But since the only answer I got algebraically is not valid, I say that there is no solution to that equation. All right, our final one, number 8. We look at it again and we're saying, all right, log base 2, they get to go away. Now we're going to have a little bit more complex log problems coming up, but this is a basic concept we need to know. When you got a log on both sides, they go away. But remember what we did yesterday. If there would have been a log on one side and not the other, move the base convert. All right, so remember there's 2 different types of log equations we have now. But to solve this one, we take x squared is equal to 6x. Now, how do we solve a problem that has x squared and x? We solve by factoring. So we need to move everything to one side. I'll minus the 6x to the left side. And I'll solve by factoring by GCF. So they have a greatest common factor of x. I pull out the greatest common factor and I multiply by its leftovers. X minus 6, and that still equals 0. Now, since a factored or a multiplication problem equals 0, I can do front equals 0, back equals 0. When I solve them separately, you will get x is equal to 0. You will get, when you take x minus 6 equal to 0, you add 6, leaving you a final solution of 6. But again, don't box, plug in. Here we saw the answer of 0 is valid. This one's not going to be valid. Because when we take 0 and plug it into 0 squared, it makes 0. Our argument has to be positive, and 0 is not a positive value. So this is not valid. But when we plug in 6, 6 squared is 36, that's good. 6 times 6 is 36, it makes both arguments positive. It is a valid solution. I hope this helps you guys finish in your 8.5 notes. Again, you can watch this as many times as you need, and it's your boy, Mr. P. Have a good day.